Geometric sequences, day 1. A geometric sequence is a sequence in which each term can be obtained from the previous one by multiplying by the same non-zero constant. So it's very similar to what we did before, but instead of adding on each term, we are going to multiply. The general formula for this is u of n equals u sub 1 times r to the n minus 1, where u of n is the first term, r is the common ratio, and n is the number of the term. And I want to go back and remind you a little bit about last time. Last time we did stuff like 2, 4, 6, 8, ... That was our sequence. And so we'd say our common difference, I hope you can see it, would be plus 2 each time. And we would find that by saying a term minus the previous term. So 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. So because we're adding each time, to figure it out, we subtract. And really this was the term un plus 1, and this is the un. So it's some term and the term in front of it, or the term after it, and we subtract. R has a similar thing, except instead of adding by 2, maybe we would multiply by 2. We are timesing by 2. And so if we wanted to figure out that it was times by 2, I mean, we can clearly see it, but if we needed to check because we couldn't see it, we do 4 divided by 2 is 2. 8 divided by 2, not 2. 8 divided by 4 is 2. And so the formula for that is R is u of n plus 1 over u of n. This one, that's the u of n plus 1, divided by the one previous to figure out what we multiplied it by to get the next one. And let's do an example of that. Now, let me give you a couple more examples. So, for example, we could have 2, 10, 50, 250, and I think that you could find out that the r there is 5. If not, you'd go 10 divided by 2 is 5, 50 divided by 10 is 5, 250 divided by 50 is 5. We could also have 2, negative 10, 50, negative 250. And if ever these signs are alternating, that means your ratio must be negative, because a positive times a negative is a negative times a negative is a positive, and so on and so forth. So if you ever see the signs alternating, it's because your r is negative. So here's a basic sequence, 2, 4, 2, 1, and 1/2, and we want to show that it's geometric. So just like we did last time, we are going to show what r is. So we take this one and divide by this one. 4 over 8, and that's 1/2. So really we just times 8 by 1/2. 2 over 4, that's 1/2. 1 over 2, that's 1/2. And then of course 1/2 over 1, that's 1/2. And so what we could say, therefore, assuming the pattern continues, and terms are multiplied by 1/2, then it is a geometric sequence. Okay? Just like we did before. Now to find the general formula, it's exactly like what we did before. You write it down. and then plug in what we know. So we want to find u of n. We know u of 1 is 8. We know that our r is 1/2, and then we want to keep the n. And it's nice because here you don't really want to simplify. You may see it simplified, but you don't need to on a test. And let me show you one simplification just to show you what I mean. If we have u of n equals 8 times 1/2 to the n minus 1, well, we know 8 is 2 cubed. And we also know that 1/2 is 2 to the negative 1. And then we have an exponent rule that says that if we have this raised to this, we just multiply them. So that's 2 cubed, and this becomes 2 to the negative n plus 1. And now if we have two things with the same base that are multiplied, we add the exponents. So that would give us 2, and then we're going to add like terms, so 3 and 1, 2 to the 4 minus n. So this is the simplified version. And I'm going to show you what I mean. Just like before, where we got an answer like this, but then we used algebra to simplify it to 7n minus 5. For the geometric, we got the answer in the box, but we used algebra to simplify it to 2 to the 4n, or 2 to the 4 minus n. Luckily for you, they are okay with this one when we're talking geometric. And then of course it says, now use that formula to find the 12th term. So that's u to the 12 equals 8 to the 1/2 times 12 minus 1, all right, which is 8 to the 1/2 to the 11. You're welcome to use your calculator for this, and you'd get 1 over 256. So the 11th term is 1 over 256. All right, the next example is finding k, just like we did last time, but this time with these. So again, we know that we have 3 terms in a sequence. We don't know if they're first, second, or third, fourth, fifth, or whatever, but we know that they're represented by some number minus 1, 2 times some number, and 21 minus that number. Okay? So we're going to use our formula, which was r equals u to the n plus 1 over u to the n, which again means it's one of this one minus this one, and this one minus this one. And we know that they have to be the same. So we know that 2k over k minus 1 is the same as 21 minus k over 2k. Now we need to solve this, and to solve, we cross multiply. That times that, and that times that. So I'm going to do this way first. 2k times 2k, that's 4k squared, and then k minus 1, and that equals k minus 1 and 21 minus k. All right, now we have to use algebra 1 to solve this, or sorry, algebra 2, and that is 4k squared, and we're going to FOIL this side. So if we did, we would get 21k minus k squared minus 21 plus k, and we're going to combine like terms, so that's 4k squared equals, well, we have minus k squared, use that up, 1k and 21k, that's 22k, and minus 21. Now we need to move everything to the same side, and it doesn't really matter which way you go, However, I am going to move everything to the right side, so I'm going to add k squared minus 22k and add 21. And I now have, and I'm doing it to both sides, so we would get 4 plus 1k is 5k squared. And then here they cancel out, but if I minus 22k over here, I get minus 22k. And here they cancel out, but if I added 21 on the other side, I get plus 21 equals 0. Now you could factor and solve or use the quadratic formula. This actually factors. I use the guess and check method, but however you want to do it, to 5k times 7 and k plus 3. We could check that. That's negative 7k plus 15k. Wait, I might have made a mistake. Let me look at that. Oh, I sure did. It has to be a negative 3. There we go. Negative 7 plus negative 15 would give us the negative 22, and negative 7 times negative 3 would give us the positive 21. Finally, set these equal to 0 and solve. And we would find out that k equals 7/5 and k equals 3. And so what that means is that if you were to plug in either of those k's into this, both of them would turn into a geometric sequence where our r is, we don't know, let's see. So I actually paused it for a minute and plugged in k at 7/5 into k minus 1, 2k, and 21 minus k, and got this first sequence. And I did the same thing when k equals 3. Well, it's 3. See? 3 minus 1, yep, that's 2. 2 times 3, yep, that's 6. And 21 minus 3 should be 18. There we go. And if you checked this divided by this, you'd get r is 7. And I think you can tell 2 times 7 would give a numerator of 14. 14 times 7 would give a new numerator of 98. And then obviously on this one, the r is 3. So yes, with these two k's, we're able to make a geometric sequence represented by these expressions with their mystery k. All right, for the next one, we need to find the general term u of n for a geometric sequence given that u of 2 equals negative 6 and u of 5 equals 162. And I am going to stop this here and do that on video part